Welcome to the first lesson of this year. It's going to be a skill review on fractions. Now, I know normally we hear fractions and all of a sudden we're like, math, this is the part that we really don't like about it. But we're going to change that. This year, fractions are going to become your friends. Something that I've seen a lot of in the past is students know how to do a type of problem. They understand the process. But then all of a sudden, we do the same process and fractions are involved and they think they can't do it. Fractions are really just like any other number. So the point of this lesson is to get you guys feeling confident with using fractions so that way when you see it in a problem, it doesn't throw you off and you can treat it just like any other number. Let's start off with our rules for multiplication. When we're multiplying, all we're going to do is we're going to multiply across the top and the bottom. And remember, the top of our fraction is what we call the numerator, and the bottom of the fraction is the denominator. For our first example, we're first going to do 9 times the 4, and that is 36. Then in the denominator, we're going to do 15 times 2, which is 30. Then we always want to make sure we remember to reduce our fractions. 36 and 30, both of these numbers can be divided by 6. So 36 divided by 6 is 6, 30 divided by 6 is 5, and here is our simplified answer. Next example, we're going to do a similar thing, although this time we're multiplying a positive and a negative together. So we're just going to use our rules for multiplication with that. Starting off with the numerator, we're going to have 6 times 4, and that is 24. In the denominator, we have 5 times 7, which is 35. But then we had a positive multiplied by a negative, which means our final answer is negative. We check 24 and 35. They do not have any numbers in common, so that is our final answer. With division, it's very similar to multiplication. The only thing is we need to flip the second fraction, and then we can multiply. In the first example, we're going to keep that first fraction the same, 13 over 4. But we're going to flip our second one, so it's going to now be multiplying by 3 over 8. Go ahead and multiply straight across, and we will have 39 over 32. This is already in simplest form since 39 and 32 do not have any other numbers in common. The second example is doing division just like the first, but it's just written a little bit differently. We could rewrite it as 12 over 5 divided by 2 over 3. Remember that fraction lines really just mean division is happening. So when you have one fraction on top of a second fraction, you could rewrite it in this format. Now pause the video, try this problem on your own, and come back to check your answer. Once you flip the second fraction and multiply, you'll get 36 over 10. And if you got to that point, awesome. But make sure that you always check to reduce your fraction. In this case, you can divide both numbers by 2, and the final answer is going to be 18 over 5. Last up, we have addition and subtraction. The important thing to remember here for our rules is we need to have a common denominator. And again, that denominator is the bottom portion of our fraction. In our first example, the denominator is 5 for both, so we're going to add across the numerator or the top of the fraction to get 8, and then we'll keep the denominator the same as a 5. With the second example, our denominator has a 7 and a 28, obviously different numbers. So we need to ask ourselves, what is the smallest number that both 7 and 28 have in common? You first always want to check and see if your smaller number fits inside your bigger number. 7 fits into 28, and it does so 4 times. So that means in order for 7 to become 28, we need to multiply it by a 4. But fractions have to be kept the same. So if we multiply the bottom, we also need to multiply the top by that same number. So we're going to multiply that first fraction by 4 over 4, and this is now going to become 8 over 28. Then we're going to add that second fraction, 5 over 28. Now we're ready to add across the numerator, which is 13, and keep the denominator the same, 28. And there is our final answer. Third example, we're going to look at our denominators. which are different, 3 and 8. 3 does not fit into 8 though, so this means we're going to have to end up multiplying both fractions. The smallest number that both 3 and 8 can fit into is going to be 24. In order for 3 to become 24, it needs to be multiplied by 8. So we'll do that to both the top and the bottom. In order for 8 to become 24, it needs to be multiplied by 3. So we'll multiply the top and the bottom by that. This means we're now going to have 8 over 24, and we're subtracting 15 over 24. 8 minus 15 is going to be a negative, since the 15 is larger and it has the negative on it. So that's going to become negative 7. The denominator stays the same as 24. And here is our final answer. On all three of these examples, the answer was already given in simplest form, but still make sure that you're checking to see if you can reduce your answer before circling it. And here we have fractions. So if you have any questions, make sure you bring those to class while we're doing our activity.